Hospitals in remote areas are often faced with a lack of medical supplies caused by the lack of available transportation. This causes hospitals to be less effective in their given conditions.
Our team realized our clients require a cost-effective solution, so we implemented a subscription-based service. To do this, we implemented various manufacturing techniques. Some of these include injection molding, no specialized components, and modular design. We also considered how the drone would affect the environment, and so we went with an electric-powered train and added a camera to minimize any wildlife damage. Finally, we used AI to add an autopilot feature for ease of operation and cloud features allowing the monitoring of packages.
Carbon fiber frames the aircraft, make its way low for maximum flying range. That also protect the aircraft inner elements, such as lithium batteries. Minimal moving parts allow low bill of material. Also, a software is designed to track the device.
4 propellers give it vertical thrust and 2 propellers give horizontal thrust, allowing it to have maximum range and flight time. The center is where the pod goes and carries the payload, allowing for quick payload reload time. The 2 side pods are where the batteries are held, and the 2 vents in the front is where air for cooling of the batteries goes for allowing maximum energy to be extracted. Once the payload is in, the user uses a tablet to send the drone to its desired destination. This is a unique solution since we incorporate both vertical and horizontal thrust without any moving parts. We also use a full user replaceable shell which prevents frame damage and allows the drone to travel in rough conditions.
The team's outcome would be a world that could rapidly transport medical equipment in emergent situations, helping millions of people.